To respected participants, a very warm welcome to GMA webinar. We are privileged to have among us Shri Atul Joshi from Alpha Level and Shri Ajay Tiwari from Barrage as a speaker from industry. Shri Atul Joshi is a seasoned business leader with a strong engineering foundation and over 27 years of experience across diverse techno-commercial roles. His career spans across renowned organizations such as Kirloskar Brothers and Alpha Laval, which gives him extensive exposure to industries including food and beverages, pharmaceuticals, refrigeration, light manufacturing, steel and metals utilities, data centers, and HVAC. Currently serving as the business head for Separation Technology Business Unit, he specializes in separation technologies and heat exchangers. A committed advocate for sustainability, circularity, and decarbonization, he is known for campaigning innovation solutions and driving change management to support cleaner and more efficient industrial operations. Our second speaker is Sri Sanjay Tiwari. Sri Sanjay Tiwari is BTech in Chemical Engineering, UDCT, NMU, Assistant General Manager at Barrage Industries Limited, having 19 plus years of experience in the distilleries and brewery sectors, covering process engineering, plant commissioning, and technical sales. As Assistant Manager, General Manager at Barrage Industries, he leads sales and business development for distillery projects and value-added solutions, such as distilleries corn oil, with a focus on a solution-oriented approach to client, with a proven track record of delivering value. I would now like to invite our knowledge partner to start knowledge share. Over to you, Mr. Joshi.
Yeah, thank you, madam. And good evening to all the attendees here. As introduced, my name is Atul Joshi. Me and Ajay will run this webinar today. Some part I will be covering, and the latter part Ajay will talk about more about the systems and so on. That's how we have organized it. So without spending too much time, I will start with the presentation. I will be sharing my screen now. And maybe I would need someone to confirm that you all are able to see my screen.
Yes, sir, it is visible and you are audible.
Is it?
Yes, sir.
Thanks. So today we will be speaking about maximizing the corn oil recovery. So that's the topic we have for today. And when we say that we have to maximize the recovery, means exactly we have to secure a quality of an oil and also the quantity of an oil. When it comes to the quality, it's most important that whatever the oil will get separated needs to comply with the global specification of an corn oil, such as there are various components I have mentioned here, for example, moisture, acid value, SAF value, and so on. And the specification limits are being specified. For example, moisture is less than 1% acceptable. And below, you will also see that how important this component is into and further further processes. For example, moisture is very critical in biodiesel manufacturing. It has to be as low as possible. Same goes to with an acid value when it comes to SAF manufacturing, and also when you are talking about renewable diesel. So these are basically the end use of an corn oil, which will be separated in distilleries. On the other side, when we talk about quantity, we have to see that how many liters per day corn oil we are generating or separating out from the system. And when we look at the composition of an maize, I mean, the oil is essentially a part of an germ, basically. And if we try to really quantify it, so the oil contributes to an 3% of an total crushing what we will do per day basis. So this is something and value or a quantity available for separation, and we'll have to see how much we can really separate out, and are we able to separate out in full, or up to what efficiency we can separate out in a system. So this is something what we will be talking today. Again, there are other factors which we also needs to consider while we wanted to secure a quality and quantity of an corn oil. For example, when we talk about separation system, which is the best suitable location in the plant where we can put the separating system, and we try to recover the oil to a maximum extent possible. The second parameter is that oil needs any pretreatment, because when we talk about available corn oil content of around 3% into the total crushing of a corn per day basis, if we have to really separate out, do we need any pretreatment? Otherwise, what we know, oil are always kind of an hygroscopic in nature. That means they tend to attract the moisture and try to start forming a kind of an emulsions. And if the emulsions are formed, it is really difficult to separate in a mechanical way. Then you need to go real with an acid treatments and so on. So we really need to think whether there is a pre-treatment required. And this is something which I will cover going forward. Then also it's important to choose the correct separation equipment. There are various separation equipments available, technologies are available. Which is the best one which we can look for, so that we can maximize on recovery, securing the quality as well as quantity. The fourth one is also whatever the equipment we will be selecting, how reliable that is, and what kind of features that has, which helps me to maximize the recovery. This is also important because the plant will run 24 by 7. So equipment also needs to be reliable in terms of its operation, and it should carry certain features which helps to generate more oil or separate more oil as far as possible. So I will touch base on these four parameters in my subsequent slides. The first one is about the location, and this is the I have just drawn from the whole stillage side. Then we do the dewatering, then the DDGS way it has been formed, and whatever the centrate which is coming out of decanters, then is going to an evaporation systems, and then finally the cake are going for the or concentrate is going for the drying process to make the DDGS. So separation equipment can be put at these three levels. You can also think of putting it at whole stillage. You can also putting in terms of in between the evaporators after second effect, or you can also put it at the end of the evaporators also. So this is the locations where one can really try to put the separation equipment. And in this table, I have just indicated pros and cons of putting the separation equipments at different stages, basically. At whole stillage, if we say, generally the volumes are very high. So the quantity of uh, amount of water solids are very high. And if that is to be handled, then you really need a bigger size of equipment, which adds into sorry, it's a spelling mistake, but it's add into the capex side of it. At the same time, a lot of solids are also there, and those solids will also increase the viscosity of a feed, and that's where you end up in selecting a bigger equipment uh, if we really you want to separate out the oil at this particular stage. And you know that this is bit an area where the solids which comes out, they are some kind of an abrasive in nature, which can lead to a kind of an higher maintenance if we try to put the any separating equipment for corn oil at location one, that is at whole stillage. Then the second location is about thin slope after the second effect, I would say. So it's a relatively low volume because you have evaporated certain water here. And also, since the solid concentration is low, so it's a kind of a moderate viscosity what you will have here. uh, and this is where you can have an optimum size of an equipment and also the capex, because that if the viscosity is high, then it is difficult for separation, because separation efficiency is inversely proportional to one viscosity. Just like if we try to put some stone in the water, it will travel very fast and settle at the bottom. But if the same stone, if we try to put into a tomato ketchup, which is a viscous one, that stone will travel down, but it will take more time to settle down. So it has the lower velocity, and that's what viscosity is inversely proportional to separation efficiency. So if you put it at location 2, then you can really go with the optimum size. And also, since this is fairly clean fluids are coming here, there would be lower OPEX in terms of maintenance requirement. And another important thing is that the corn oil present into the feed also form a kind of films or the scales onto the evaporator surfaces. So we can really avoid fouling of evaporator because of oil part into the next effects basically, and that's where you will end up in having a less cleaning time for evaporators. So this is something a good location, I would say. And then the third is after the complete, I would say, the thick slope. Uh, I would say here, where after the evaporator, whatever the concentrate comes in. Again, since this is a concentrated, maximum water has been evaporated, so a lot of solids are here. So it will again increases the viscosity. And as I said, viscosity is inversely proportional. You again end up into the selecting a bigger size of equipment to achieve same separation efficiency. And that's where you end up into buying an parts which is bigger than required size, increases your maintenance cost. You will also by the time have a fouling in evaporators because of the oil films. So that's something which you would like to avoid, which can end up into more cleaning times and so on. So you will lose on to the production time. So we generally feel this is the good place where one should put the separation equipment. Now, as I was talking about the pre-treatment of a thin slope, why it is required basically, and I'm trying to show you some of the spin tests which we have done on the thin slope, and that the spin tests have been done to really see how simple the separation is, or is it really a difficult one. So the spin test which we did for thin slope without pre-treatment, and that we did at different RPMs, 3000 RPMs for 2 minutes. Sorry, not different RPM, but different time. 3000 RPM for 2 minutes and 3000 RPM for 4 minutes. What we saw here, we could not see a clear layer of oil floating at the top in this area. But and also when we check that into the microscope, what we found that there are many small size droplets of oil we have seen here basically. So the oil particles are very small, and we could not see a clear layer of an oil here. What does it mean? That it is a kind of a weak emulsion phase at its top, and in the mechanical separation, separating an emulsion is a really difficult task basically. And again, having these small droplets will need a higher force for separation, and as well as for the higher area of a separation. So you end up into a bigger machine, or with the same machine you end up into generating less quantity of an oil. So that's how it will uh, result. And it being an emulsion, clarity of an oil, what we are talking about, the quality of an oil meeting to the specification of oils, you will tend to lose here. But after doing some kind of an pre-treatment, what we saw, we can clearly see a visible red color oil layer. And when we observe that in microscope, we also see a lot of large size particle. So being a large size particle available, it becomes quite easy for separation. Uh, and that's where, we see that if we do a pre-treatment, there is a great possibility that we can separate more oil in quantity out of available into a con. So the per day we can produce more oil. I mean, it can be in liters, or you can measure into a tons per day basis also. But this is what something pre-treatment is helping here. So it's very essential that if we really want to maximize the recovery, we should think of doing the pre-treatment for thin slope. What this pre-treatment can be, I mean, it can be a kind of to break a weak emulsion, maybe a chemical process a bit, which involves reaction time, what chemicals, dosing, etc. It probably also needs to be done at an elevated temperature. So higher temperature, lower the viscosity, better the separation. So you may need a heating, and also since the corn contains a lot of fibers, so it is important that those fibers does not come to one separation equipment. So probably you will need some kind of coarse particle separation before it really goes into an equipment. And Ajay will really talk in more detail about this, but this is just an overview about a pre-treatment, what I am trying to show here. Now, I come to selection of an separation equipment, and I would first start with the theory of an separation. On to the right side, there is an images or the pictures which shows the two particles. One is bigger and one another is a smaller, and these particles will settle down. So the bigger one will settle faster than the smaller one. So it is time dependent process. But I think the velocity these particles attain in the settling or the sedimentation process are being calculated by a law which is been derived by a scientist Stokes. So it is called as the Stokes law. And what it talks about, the velocity for separation the particle will attain is basically a function of an particle size, the density difference between the particle and a liquid, and also in viscosity. And this entire process is happening under the force of gravity. Right. So if you really try to see that, what it says that if the particle size is bigger, then the settling velocity will be higher. So the separation efficiency will be better. Same goes with density difference. If there is a greater density difference between liquid and the solid, then the settling velocity will be higher and the separation efficiency will be better. But it is inversely proportional to on viscosity, as I was talking to you about it. And at the same time, when anyone has to select an separation equipment, one has to also see different properties of a liquid. One, how that liquid, I mean, particle sizes are there, how the density difference, how is the viscosity of a liquid. But other than that, we will also see that how the angle of repose these particles can form. An angle of repose is something if you try to pour the dry particles on the flat surface, what kind of shape, whether they form a crest like a mountain or they are really flatten and onto the surface. Just a simple example I'm trying to tell you. Then also we'll have to see that whether these particles are shear thinning or thickening, Newtonian, like water is Newtonian. You apply any force, I mean, it will absorb that, and it will form a shape accordingly. Corn generally it's kind of a shear thinning. So if you apply the force onto the particle, they will try to move towards the flow, or along with the water, it can come out. So those are shear thinning nature. The corn particles are. And you know what amount of solids and everything. So all those properties also one has to really see while selecting the equipment. There are certain guiding principle. You have different technologies available, as I said, and in this graph, it is a general guideline where on the x-axis you will see the particle sizes. So from smaller to bigger one, and onto the y-axis you will see the percentage of those solids present in a liquid. So if we are talking about a very fine particle separation, let's say that something less than 1 micron or below that, then membranes becomes the suitable equipment. But if, let's say, we are talking about particle, let's say close to 500 microns, and the percentage close to 25 20 to 25%, then high speed separators becomes a perfect fit. And beyond that, if the particles are really bigger and also they are more in the volume, then the decanters or the tricanters can be used. And obviously, one has to understand that when you use for high speed separator, it has high G force and as well as high area for separation available, compared to decanter or tricanter, where those are rotating at a lower RPM. So sorry, they have a lower G force, and also the area equivalent is low in that. So this is something very important to understand while selecting an equipment for separation purpose. Then another important fact is that suppose one decides to go with high speed separator, then it is also important which configuration of a high speed separator is good. For example, these are three types of bowl in high-speed separators available. The first one is a clarifier where one inlet and one outlet will be there. So that means it is only used for separating the particles from the liquid. Another one is the purifier where there will be one inlet and two outlet will be there. So two outlet would be necessary, the liquids. One is the lighter liquid and another one a heavy liquid. But what happens here, the light phase is dominant. For example, if you want to separate the oil, water from the oil, then you go for with the purifier, because the oil is more in volume and the water is less basically. So that's the purifier application. And then the third one is a concentrator type of a machine or a bowl, where again two liquid will be separated and also the solids will be separated. But here the heavy phase dominates. For example, exactly the corn oil application, I would say, or another application just for understanding. If you want to skim the cream from the milk, then concentrator machines are used, where you have one inlet and two outlet, where the light phase is low in volume and heavy phase is more in volume. And exactly this is what is happening when it comes to a corn oil separation, where the water and the solid phase is more in volume, whereas the oil layer is very less in volume. And that's where very important that whenever you go for the corn oil application, you must go with the concentrator type of a bowl, where the holes on the disc are very close to the center. So what happens, the feed is distributed from this hole, and then the heavy particles, heavier material travels toward the periphery, and the lighter travels toward the center of the machine. So the heavy particles or heavy phase gets a more area for separation, thereby you separate maximum oil out of it, and then you recover more out of that. So that's the principle why the distribution holes are very crucial while selecting the application. And in the corn oil, it's a concentrated bowl, suits well than purifier option. Then it's also important is that how the separated liquid is coming out, because oil we are separating out and we'll have to see at what quality. I mean, one, we do the pre-treatment where we make it easy for separation, and then do in the equipment where we are separating out, we have to ensure a clarity between two phases, water phase and oil phase. And there are two options available. I mean, one is that I will explain this right one side, where you see that the blue color is water and solids, and the yellow color is basically an oil phase. And the oil phase has here one pump, okay, to pump it out, and also this water phase also has a pump to pump it out. So this is one option available where, the both outlet, oil as well as the water, will come at certain pressure, and you can transport it directly to somewhere into a tank location. But the disadvantage in this system happens is that the if you try to look at internally into the bowl, uh, this is the area for the heavy phase. Suppose this pump sucks more, then what will happen? This line, which is we call as the interface, will tend to move towards this side. So what will happen? Some oil might escape from this side, which you don't want. Other way, if this pump sucks more, then what will happen? This line, which is here as an interface, will try to move towards the center, and then some water will come along with an oil. So you will have the oil with higher moisture content basically. So it might be more than 1%, it can be 2% or 3%, like that. You will still separate the oil, but you will not achieve the clarity, because these two pumps, it is very difficult to balance this interface position exactly in a bowl, so you get a clarity of the liquid of the both phases. So this is advantage is that you don't need a pump, but disadvantage that you lose on to unclarity, and probably that's where you might lose on to the while you try to sell this corn oil, there would be a challenge in terms of prices, because the buyer has to do some further process to make sure that the oil meets the specifications and so on. The other one is that you have the pump onto one side, and the second is open basically. So what happens? It's only a one pump which acts, and the other side very free flow liquid comes out. And I think this is very good position or very good design for concentrated type of machine and for the oil recovery part, where the oil will come free flow basically. In this case it is shown in the other way, but just for illustration I am showing you one pump and one is open outlet, we call it as it, which is very good for securing the quality of the machine. And this is where we have seen, because we have both types of machines, and when we use it for the same application, we have seen in the concentrated application specifically, the open outlet gives you better quality compared to both outlet as with the pump basically. And the reason I explained that, these pumps, it is very difficult to maintain this imaginary line. It can move anyway depending upon the what the kind of an suction power happens onto the pump side. So this is also a very important feature when you select any separation equipment, and this is specifically when you decide to go with high-speed separator. So when it comes to an alpha Laval side, generally AFPX 200 separation system as a concentrator we supply for corn oil separation system. So it has a concentrator type bowl with gravity. So that's an open outlet for oil. Comes as a modular design, easy for installation. It is an intermittent discharge type, rotates at an 7,000 RPM, and almost having an area close to 52,000 square meter. And install motor is close to 22 kilowatt. So this is all about the equipment, and I'm a little bit talking about our capabilities onto the service side as an Alfa Laval. I mean, we have the entire ecosystem available in India. So we have sales and service support team. We have some partners who does some products. We have claim support teams here. We have the parts distribution center in Pune. We are also having a team which is there available during the day for supporting customer remotely. So they provide a remote guidance. We have the on-site engineers to deliver our services. And we also have our service centers, 3 service centers located all across India. So this is something, an ecosystem what we have. And you can see almost more than 85 service engineers what we have at in different locations. So you can see that we cover install base, and the engineers can reach to the install base as quick as possible. Then obviously we can help our customers during startup, during the operation of an equipment. If customers needs any optimization, we can be there. And if any renewal in the change in the process is there, if something to be modified in the machine, so this is something what we can do. So we have a full ecosystem available with us. So this is what I thought of talking about it. And when we were talking about having a high-speed separator and also a pre-treatment system, I think Alfa Laval and Praj has combinedly developed a kind of a solution which helps to maximize recovery, securing the quality as well as the maximum quantity. And I will request Ajay to take the further things. Over to you, Ajay. And any questions? I think once we are complete, then we can take any questions and answer. I hope that is okay with you all.
Yeah. So thank you, Atulji, for the detailed presentation on the extraction part of it. And thank you, GEMA participant, and thank you, GEMA, for giving us this platform to present our solution on the corn oil recovery. I'll just close the video for the sake of better bandwidth. So Atul, my request will be just to move on the slide as and when I say next slide. So
I will do that, Ajay.
Yeah. So until now, we got to know the detail of how extraction helps us to recover oil from the in the corn oil extraction process. But actually, if you see the solution, what we are offering is along with the Hello. Yeah. So, I'll run through some detailed part on the pre-treatment part, just like how oil helps us to extract the oil from the solution. But pre-treatment is what helps us to liberate the oil from the mixture, because as we all are aware of this process, corn to ethanol process. When the corn is crushed, oil is released out of this germ, and during the process of liquefaction and fermentation, due to its certain temperature profile, most of the oil which are released gets bounded into these small particles of these fibers and protein. So this oil has to be liberated, so that once we send it to the extraction unit, we get a better recovery, better or higher recovery. So we will explain in few slides. We will explain you how we are carrying out our process. As you saw in one of the slide, wherein oil extraction can be carried out at 3 different parts. So we during our trials, we have firmed up that the best possible position for our extraction will be after the evaporation, basically. During evaporation, basically, like, if I have to say. So what we do normally in our conventional process, wherein after the decantation, the whole stillage is sent to the evaporator. At third or fourth effect, seeing the temperature profile, we take the thin stillage and send it to our DCO unit. wherein we carry out our pre-treatment part. And pre-treatment part basically we carry out in two ways. Basically, one is the thermal treatment, other one is the chemical treatment. Atul, can you move to the next slide, please?
I think this I explained. I will move to the next one, right?
Yeah. So as you can see in the, you can I'll add something on that slide. Atul, the previous slide, please. So as you can see, how the difference is there between the process which is run without pre-treatment and the process which is run after pre-treatment. Now, in the pre-treatment part, if you see, we are carrying out two basic important stages. One is the thermal treatment, wherein we raise the temperature of our syrup going into the DCO at certain temperature, where we make sure that viscosity is reduced, and the moment the viscosity is reduced, the oil is liberated. And at the same time, it is followed by the chemical treatment part, because even if the oil is removed, we need to make sure that the one point wherein Atul explained that separator works much better when you have a higher molecule sizes. So second part, that is the in second part of the chemical treatment, we normally do the coalescence, basically coagulations of this all smaller droplet of molecules, so that it forms a bigger molecules. And once the bigger molecules are formed, the separation efficiency is highly increased. So that's why if you see how the molecule sizes have also changed with the pre-treatment, that helps to increase the efficiency of your recovery. Basically, what we have found, normally there is an increase in at least 33% of recovery with and without pre-treatment. Yeah, next slide, please. So as a complete package, what we are offering the first part as a syrup conditioning. We take the tapping from the evaporation plant, effect 4, and as since the equipment since the syrup has to pass through various critical equipments, we make sure that it is protected at various stages. So before syrup creating, we have an automatic brush filter, so that it restricts the sizes of the particle, and then syrup creating is done, wherein temperature is raised up to roughly 80 to 90 degrees Celsius, just to make sure that oil is liberated and viscosity is reduced and oil is liberated. And once the temperature is achieved, we send it to the reactor. Atul, can you just press the button? So in the reactor, this part covers the syrup conditioning part, wherein oil is released, basically. So once the oil is released, there is the second part of the pre-treatment, where we carry out chemical treatment. A certain amount of dosage of surfactants are done, which we call as de-emulsifier. So this de-emulsifiers helps to bring all the smaller molecules of your oil to form a bigger molecule, and certain residence times are provided, so that you get better global formation is taking place over there. So once the chemical treatment is done, it is sent to the extraction part of it. Atul, can you next? So here the extraction part already Atul has explained. So what we do, we make sure that for the better extraction, whatever the things are required, like reducing the viscosity, liberating the oil, then coalescence of the various smaller molecules of oil. So those things are performed in pre-treatment part. And once the pre-treatment is done, then the extraction, what Atul has already explained, we get a better recovery. In fact, recovery is much better than what we have found without pre-treatment. Now, that further the process is followed by the syrup polishing, oil polishing, and the storage part. Basically, what happens during the optimization of our pre-treatment, because if you see, while corn is crushed during the milling part and in the liquefaction and fermentation, there is a possibility that some soluble wax might be released, because at the pre-treatment level, during the heating part of it, thermal part of it, the chances are there, in order to increase the release of oil, some wax might also be released. But we during the process, during the commissioning stage, we find a sweet spot wherein the temperature is optimized in such a way that we get maximum release, and wax release is also very minimal. But in order to have a safeguard, because what happens, some of the buyers, especially the biodiesel application, they want wax to be at a very minimum. So what we do, we have a polishing tanks. Basically, it's basically a sedimentation tank. So we have a special design wherein it is also called a score tank. So in that score tank, the oil is allowed to store for certain intervals, which allows wax to settle down, and then that wax is removed. And wax is in very minute quantity, hardly in grams, basically milligrams, you can say. So, but those things do affect the pricing of your oil. So that is also taken care during the solution. Finally, once the oil is cooled, wax are removed, it is sent to a product storage, just like our peso storage or ENS storage. It's simply a storage tank. Yeah, so next slide, please. Atul, so these are some of the studies what we have found, like optimization of temperature is very important. Otherwise, the coloring, DDGS coloration might get affected. What we have found at around 80 to 90 degrees Celsius in between for an Indian corn, during our trial at New Way Homes, we found that this is the best optimized temperature for Indian corn, wherein the color is maintained and the value of DDG is not affected. The other picture which you are seeing, it's the same. This is during the trial what we had studied. So in one of the batch we found this occurrence, because primarily, as you see, at higher temperature more oil will be released, but then that leads to the caramelization effect. So optimization of temperature is very important, and together with Alpha Lab, we have established what parameters has to be done for the Indian corn. Yeah, Atul, next slide, please. These are some of the engineering aspect what was studied during the trial. Like one was that we need to have the rotary that automatic filter so as to avoid any choking during the syrup conditioning stage. The chances of scaling is very high due to this solid. Followed by also we did trial with both the heaters, that the best way possible will be to go with the wide gap PHE, because in the wide gap PHE we can have number of passes so as to have better turbulence, and it avoids your charging effect basically. So temperature is also raised, but at the same time at a lower temperature we can get a better effect with number of passes. So this is also fine, which we have learned during the trial. So we have firmed up the design that we will be having a wide gap PHE for the design. Yeah, next slide, please. Like basically, yeah, Atul.
Yeah. So this is next slide, please. Yeah, you are seeing on section 2, right? Hello.
Next slide.
Yeah.
This
I
I
am
think
at the
already
slide.
covered. We can move to, yeah.
Okay, great.
Yeah, you can move to next slide. Yeah.
Okay. Is this the one, Ajay?
Yeah, Atul, please move to the next slide.
That's a trial ones, right? Hello, Ajay. Hello, Ajay. Am I audible to others?
Yes, sir, you are audible to others. I think there
Yes.
must be some technical issues from the second speaker side. So he left.
Okay. Uh-huh. Okay. So maybe we wait for.
Disconnected.
Yeah, Ajay.
Yeah.
Sir, he's back.
Yeah, am I audible?
Yeah, sir, you are
Yes,
audible.
Ajay, you are audible.
Yeah, so basically, these are some of the trial data of our first plant which got commissioned 1.5 years before. So these are some, like the basic summary. If you see, we were able to establish the good parameters which is required by our buyers. And also one thing got confirmed, that along with thermal treatment, pre-treatment also helps us to increase our recovery, because there are cases that even in some cases we might feel ki let's do only the thermal part of it. Why to do chemical part of it? But we found together the combination helps us to better recovery. We can increase the recovery up to 33%. And these are on an average, if you see, per ton of corn fed will approximately, we will be able to get around 14 to 15 liters of corn oil, basically. Yeah, Atul, next slide, please. Next slide, yeah. These are some of the next slide,
what we
Atul.
have, right?
Yeah. These are the samples. So some of the key features what we have, since already this trial has been conducted on Indian corn, so we have parameters established. And as we discuss about the importance of pre-treatment, the profitability increases which along with pre-treatment and the better design of extractor. And it can be a plug and play design. Like we can design the plant at our workshop and just have with the minimum shutdown, we can integrate in the existing distillery. And one thing is also observed that since most of the buyers till date were looking for protein percentage. So what happens once the protein, once we recover the oil, in the absolute term, protein percentage actually increases. So some of the nutritionists find oil with low DDG, low fat, DDGS with low fat as a better feature, basically. So that is also improved. That is one of the advantage what we find. Yeah, cool. Next slide. So as far as utility requirement is goes, since we are carrying out the thermal treatment during our process, instead of steam, we are using steam condensate. So that ensures a very delicate heating up of the syrup instead of using steam, wherein charring is possible. So within the utilities, it's like within the plant, like from evaporation or either from distillation, the same condensate can be used as the heating media. And power also for a small one single size of separator will require hardly 50 to 60 kilowatt per hour. That is the requirement of the utility. Yeah, Atul, next slide. So these are the different models of DCO which we have standardized based on the capacity, like up to 125 plus minus 10%. It can we have model DCO S, basically with one separator. And once we go beyond 125, that is up to 250 KLPD, we have two separator design. And reactors and other design will vary accordingly. The sizes will vary accordingly. So these are the various models what we have, and we can design the plant up to 625 KLPD. In fact, we have some references varying from 125 even up to 625 KLPD. Yeah, Atul, next slide. So these are some of the advantages, like the long-term advantage. If you find the, since we have already done the study, so we know the like there is no trial and error method required. So we are aware of what are the basic parameters required and what are the importance of various sections in the DCO plan. So that advantage we can pass it on to you as a long-term. And plus we are also working on further value addition of this DCO. So that can be one advantage while associating with alpha laval and trash. We are working on a value added product wherein this DCO can be also used for further better application, which will fetch you a good price, basically. Short-term advantage, as we found that the skid mounting design helps us to reduce our time at site. So that can be also one better option to go for. And when it comes to establishing the market arrangement, so we have certain buyers available who are ready to buy corn oil at very lucrative rates ranging from 65 to as high as 80 rupees a kg. So that also, though it's not an that 2-3 buyers have approached us for this buyback of this oil wherever Praj Alpha Laval has a solution. Yeah, to next slide. So these are some of the references for the last 1 year. Like one plant is already in running condition. The number 6, New Way Homes. The Chairman Silk Mills Limited will be getting commission in a month's time already. And then other plants are at various stages. The largest what we have offered, what we have secured is the 600 KLPD plant, the plant coming up in Bihar basically. So this will house almost 4 separators along with the reactor system. So quite a number of references are already in place, and 50% of the for 50% of them we have arranged the buyback arrangement also. Yes. I'll leave it for you to ask because already I think we 45 minutes was allotted, so we are within the 45 minutes, so we can go for a question and answer session. Yeah. Thank you.
Oh, thank you, sir. Uh, Now you will see a poll on your screen. Kindly select the option that best reflects your view. So the question is, are you interested in maximizing your corn oil recovery? So I request everyone to give their input. Thank you for your responses. Let's take a look at the results. So 78% person said yes, and 21% said maybe. So now I'm going to end the poll.
Okay. Madam, approximate cost of the plant,
Now,
madam,
I
for
have
one
shared. I've shared the.
200 kg plant, the grain-based plant, 200 kg. Madam,
Yes, sir.
approximate cost of the plant for 200 kLPD grain-based plant.
Sir.
Next, the skid. 200
Sir.
250 kLPD.
So just give me a second. Now we are moving. So the session is now open for the questions. Please feel free to share yours.
Yeah,
Sir,
yeah,
sir, you can
Mr.
raise your question.
Basuraj. Yeah, Mr. Basuraj, what I'll do, since I'll have to go run through your battery limits and other thing, so maybe I'll get connected with you and I'll give you an estimate for the plant, basically for 250
Okay.
KLPD. Will it be okay, sir?
Okay.
Rather, we'll help you in understanding the overall feasibility as well as the ROI part of it.
Okay.
May I'll connect with the madam and get the contacts of yours, basically.
Okay, so sir, we have some questions in our chat box. So Mr. Kanan wants to know, is corn oil add value in DDGS if it passed on?
See, I'm Kannan. I have been producing DDGs for the last 5, 6 years. I was in EAD and now in Golem. We have now a distillery of 350 KLPD. But whatever I've seen on a DDGS sale, the presence of oil directly gives advantage in the color. If it is low, the color tinges changes. If it is, people normally look for if it is a maize, it's a yellow, and then rice is different. And color is an important factor, and protein is an important factor for DDG's price. And people, those I've seen even 4 to 5% oil. I've seen 8 to 9% of corn oil. Somebody tried to maintain around 8 to 9% in DDGs for better realization. I do not know whether it's a market sentiment or whether it is technically required for animal feed in such a way, because something is supplied for fishery food, something is required for poultry food. So just like to know about the DDGs character with oil, which is good as far as the DDG is concerned. Then we will decide it, extract of separate oil and then sell it as emulsifier or for biodiesel application. Yes, we will be open to it. But what, because DDGs has important revenue, I would like to have the corn oil presence in transport of commercial value on the DDGs.
Sure, sir. Atul, I'll answer this question basically since this question what you have asked, sir, this has been a primary question whenever we talk about corn oil extraction plant. So based on our interaction with various DDGS buyers as well as the plants which we have one reference which is running a DCO plant. So based on that, I'll share with you some data basically. So in our design, what we are doing, since we are extracting oil through a thin stillage, so we are able to maintain in our DDGS 7 to 8% of oil in our final DDGS. So that is one aspect which is good enough for a agri nutritionist to. In fact, it is better for him to adjust the ratio of his oil
Yeah,
in
that's
his final
fair.
product.
See, no one pass on more than 9 to 10%.
So yeah,
Okay. Normally, I understand that. That means, see, my question is what kind of oil level you are leaving in the DDGs. So now you are
7 to
told like
8%.
6 to 7%. I have seen for 6% also, 5% also. I have seen 9% also. I have seen its impact on the color. But just wanted to know. So apart from whatever this 11% per metric ton of corn, what you told is after leaving 7 to 8% or 6 to 7% corn oil in the DDGs.
Yes, sir. So 7 to 8% is the corn oil left in the DDGS, and as you rightly said, color does affect. So moment we have found the DDGS with 11% oil had certain darker shade. Not I would say completely black, but it was a darker shade, and the oil with 7 to 8% was with a lighter shade, somewhat yellowish. So in a way, actually, it improved the color when it comes to corn oil DDGS with corn oil recovery. And as far as buyer goes,
Sir,
when you
there
ask
I
the
have a
question,
point. There I have a point. When it comes to 4% and all, the color is like almost like a burnt. If you are maintaining it between 7 to 9%, the color is good. And DDGs,
yes, sir.
in fact, that's what even the export, if you are trying for DDGs, they are expecting that corn oil level to be around 7 to 9%.
Right, sir. Agree, sir. We are also on the same page, sir.
Why it is with you are talking about with extraction also 7 to 9%, without extraction also people get only 7 to 9%. No one has got beyond 10 11%. Where is it going?
Uh,
Is getting burnt or what? What is it happening in the process if I don't extract?
Actually, we have some data available from our plant. So and based on the data, what we have found, if we don't extract the oil, the DDGS fat had 11% fat content, around 11 plus 11 to 12. And after the recovery, we found 7 to 8%. We have those data we can share with you for the better understanding of the same. For the Indian corn, basically.
Or basically the 3% what we are extracting is you are talking about per metric ton, it is giving to around 90 liter of 18 or 19 per metric ton of corn.
Yeah, not in percentage. What we are like as a thumb rule, just for the sake of understanding, the per metric ton of corn fed in your process, per metric ton of corn fed in your process will give you somewhere around 14 to 15 liters of oil. Like just for the sake of example, if it is a 1,25,000 liter plant, so with a yield of around 390, you are going to use around 325 tons per day of corn daily. So
Sir, the
325,
moment you are the moment you are putting per liter per ton of corn, the capacity doesn't matter. Right.
yeah.
I have understood you are controlling the temperature with the water, not with the steam, so that burning does not happen and it caramel, whatever it is, the charring does not happen. All this point I have noted it. But my only this thing is the presence of oil and what the level optimum for the DDGS, how the pricing is linked. Thank you.
Yeah.
Gopal sir. Ji. Thank you.
Any other question? Any other question from the participant side? So next question, sir, we have in our chat box, which is from Onkar Deshpande. What is crude corn oil price and its application and impact on DDGS price?
Crude corn oil price, actually we have several buyers, like one of the buyer is using this corn oil for soap application, like they make some laundry soap. So for them moisture content is a very important factor. So they have been offering around 65 to 70 rupees a kg. And similarly, we have one buyer now, they are planning to use this for SAF application, who they will be exporting this corn oil. So there the price can go up to even 75 rupees a kg. This is how the prices vary based on application.
We can go down from staircase from here, na? Thank you.
Okay, sir, thank you. The next question is from Anirudh Ravindra, and his question is, what is recovery improvement expected in percent terms on account of pre-treatment?
Yeah, so what we found in during our trial, the combined, like pre-treatment, as I explained, the pre-treatment is the combined treatment, wherein first stage is the thermal treatment followed by the chemical treatment. And if we follow the both, we found that at least like 30 to 33% extra recovery is there, because this helps, because with pre-treatment you are also able to recover the oil which is in the bounded form. So without pre-treatment, with pre-treatment, around 30 to 33% extra oil is what we get.
Okay, sir. So the next,
I've answered. Yeah.
so sir, the next question is from Badri Vishkarma, and he want to know, DCU can affect protein percent? Can DCU affect DD's color?
DTO doesn't affect protein percentage directly, but what happens, just for the sake of example, like for a 125 KLPD plant, if we were to produce without DCO, 80 tons of DDGs would have been there. But the moment we remove, we have corn oil plant, so somewhere around 4 to 4.5 ton of your oil is removed. So in a way, your denominator gets reduced, and protein still remains the same. So protein percentage actually increases once you remove the oil. But please be aware, it's the protein percentage. In absolute term, it
Until
remains the same.
otherwise,
Absolute
Sir Tiwari,
in
that cannot
absolute
be done.
number, it remains the same. Sorry.
That cannot be done because, see, on respect to coil, you are removing, or corn, you are removing it. But DDG's weight is the density is going to come down if the oil is removed. It depends upon the directly related to, technically, it is related to the density. Okay, the coil per metric ton, if it is oil is there, the density is changing, that's a different issue. But what you have told us, basically per ton of corn, you are removing certain oil, but DDG's ka jo specification is the density going to change.
No, sir.
We need to, if the
I am
density changes,
referring.
then
See,
only this ratio will change.
No, so I am referring to a point wherein I am saying your absolute protein will not change. Your absolute amount protein amount will remain the same. But since we are removing partially the DDGS fat percentage of it, obviously your denominator decreases basically. So mathematically, theoretically, it increases by 1.25% basically. Like
The DDG's production by chance, if it is on a per metric ton of corn, if it is say for in maize, if it is come to 28 or 29%, if you remove the oil, it might come down to 29, it may come down to 27% or 26%. Right,
yeah, and
3% to our exactly.
protein remains the same, sir.
Protein remain will say.
Same, yeah.
That's what I'm saying. But what we observe is color is more important, and for DDGS sale, if you miss the color, then nothing will get sold in DDGS, and it's very important. Second is yeah, protein content is very important that we have to maintain the best.
I appreciate, sir. In fact, we have been sharing this knowledge to across the manufacturers that color and the percentage protein is more important. If we are able to maintain 7 to 8% of oil or fat in the DDGS, but there are some cases wherein some buyers are using this DDGS and then using it for solvent extraction. So they normally come, and those are hardly 5% of the buyers of DDGS. So they normally have a complaint that once you remove the oil, I will offer you a lesser price.
Okay, sir. So next question is from Badri Vishkarma. What types of demulsifier used in chemical treatment, and explain about thermal treatment limit?
Basically, these are the surfactants. And we have developed some in-house blend basically based on the trial what we have done. Basically, those are de-emulsifiers and it's a surfactant. So I think it's more. I have informed you more and there are various surfactants available. And coming to thermal treatment, basically thermal treatment, what we are doing, we are raising the temperature of your thin stillage from third or fourth effect based on your temperature available up to 82 to 90 degrees Celsius, and finding a sweet spot wherein we can get a maximum recovery, but also at the same time we are able to maintain all your other parameters of DDGs are not affected. So that is what we do it in thermal treatment, raising the temperature up to 82 to 90 degrees Celsius.
Ajay, what is the price of corn oil per liter?
Yes, corn oil, sir, as I explained you, sir, like it can vary from 65 rupees to 80 rupees a kg also. In fact, there are instances where we have heard even 90 rupees is what is being offered. But
what
on
is the
an average, you
extraction
can
cost?
consider 70
Yeah,
rupees as
what is the
average
extraction cost? What is the extraction cost?
I'll explain you, sir, separately if it's okay with you, sir.
Yeah,
There are
fine.
some costs involved.
Fine. Yeah, because capex is there, opex is there, and
Yes, sir.
variable cost
Yes.
will be there.
Yes, sir. Yes.
Ballpark number.
You are right, sir. Moment the pre-treatment is added, the capex gets increased, but the recovery is very fast, even with the opex being high, slightly increased. But that is covered. I'll share you with the details, basically, entire details of it, basically, separately.
So the last question in the chat box is from Rishabh Singh, and the question is, what is the cost behind chemical use of oil separation per liter?
That is what I answered. What I'll do, is it okay if I answer it you separately in an overall business case scenario? That will give you a better answer.
Okay, sir. So any other questions from the participant side? So since there are no more questions from the participant side, let us conclude the webinar.
Thank you.
Yeah, ma'am, one request, like few questions were asked where we will have to revert them. So will it be able, we can get the contact IDs of the same?
Yes, sir. Sure, sir. We will share it with you.
Yeah.
Okay, sir. So we are very thankful to Shri Atul Joshi and Shri Ajay Tiwari, sir, as a valuable knowledge partner. Please accept a token of appreciation from JIMA. Thank you once again.
Thank you all the participants for your time.
Thank you all for your
Patience.
valuable time and participation.
Thank you all.
Good evening, everyone.
Thank you.
Thank you, madam.
Thank you, sir. Thank you, everyone.
Yeah.
Thank you.